Hello, today in class we will solve another task where we will find the intersection point of the graphs of two linear functions. These linear functions are represented as linear equations with two variables. The first equation, x minus y minus 7 equals 0. The second equation with two variables, 5x minus 3y minus 1 equals 0. Our task is to find the intersection point of these function graphs. But we can't see the graphs of these functions, and we will not graph these functions. However, to utilize the algebraic method to find the intersection point of the graphs of these functions, we need to express one variable in terms of the other. But as we are dealing with graphs, we should express variable y in terms of variable x. In the first equation, we will express minus y as we will transfer minus 7 to the right and x to the right. Ultimately, we will arrive at 7 minus x. But keep in mind that y is written with a minus sign, so I will multiply both sides by minus 1. In the end, we will have y equal to negative 7 plus x. Let's write break as y equals x minus 7, break time 1.0. Now let's examine the second equation, 5x minus 3y minus 1 equals 0. We will use the same approach. We will maintain y on the left side. We'll shift the other terms to the right. Thus we get 1 minus 5x. Please pay attention to the variable we want south. Has a coefficient of negative 3. Therefore, I will divide both sides by minus 3. As a result, we will have y equals minus 1/3 plus 5/3. Let's rewrite this equation again. Y equals 5/3 x minus 1/3. Instead of plotting the graphs of these functions, let's apply our rule. And then we will summarize. Thus, the first graph is y equals x minus 7, and the second linear function graph is represented as 5/3 x minus 1/3. What should we do as a result? If the variable y is written on the left side of both equations, and these variables are equal to each other, then we have the right, set the right sides equal. Thus we will obtain x minus 7 is equal to 5/3, x minus 1/3. And we can solve this equation. Let us multiply both sides by 3 to eliminate the denominator equal to 3. Multiply by 3. If you do not multiply both sides and do not eliminate the denominator, you can solve this equation and deal with fractions. However, to prevent making arithmetic mistakes, I suggest removing the denominator. We multiply both the left and right sides by 3. Don't forget that we must multiply each term by 3. 3. When you multiply 3 by x, you get 3x, and subtracting 3 times 7 equals 3 times 5/3. X minus 3 multiplied by 1/3. Consequently, multiplying by 3, on the right side, I can divide both 3's by 3. And in the second addend. Consequently, our equation looks like this. 3x minus 21 equals 5x minus 1. In this case, we can find the value of x. We move the x's to one side. 3x minus 5x equals minus 1 plus 21. Thus, 3x minus 5x equals minus 2x equals minus 1 plus 21, which is 20. So, x is equal to negative 10. Next, we must find y. We can substitute the value of x into either the first equation or the second equation. And then we will have the result. Let's plug it into the first equation. X equals negative 10. Negative y minus 7 is 0. We have a single variable equation, and negative y equals 10 plus 7. Then minus y equals 17. Thus, y equals negative 17. We found the intersection point of two function graphs. Let's note it down, with coordinates minus 10 and minus 17. Now pay attention to the coordinates of the intersection point of the two function graphs. This point has coordinates of minus 10 and minus 17. If we were to draw the graphs of these functions, we would definitely discover this intersection point at those coordinates. But we would need to continue the graphs of these functions and arrive at the point with coordinates of negative 10 on the x-axis and negative 17 on the y-axis. So, when you locate the intersection point of two function graphs, unless it is specified, in the problem that you need to plot the function graphs, you can equate the right sides and thus find this point. In the next lesson, we will see how to find the intersection of function graphs with the axes. That concludes our lesson for today. Goodbye. See you soon.